What's up, everyone? Happy Facebook Live. Oh, is it going to be glitching bad? Better not be. Better not be glitching, camera.
Don't even start.
We're going to be watching. Yeah, Hannah, there's a good reason why the music is a little dramatic. This is a big storm system. Now, I've got to say this, that the tornado potential for our area, it's not as high as what's happening in Oklahoma. In fact, Oklahoma currently has 2 tornado warnings that are in progress. One that was close to Custer City, another one that's just to the southwest of Weatherford. You'll see everything's really quiet on our WeatherBug Network camera now from the Graduate Hotel, but check this out as we zoom out here. Pretty intense line that's developing. The northern end of the line is kind of falling apart, and that makes sense because there's no instability there. Instability makes a difference. A lot of lightning popping up, but let's take a look here at the very latest as we stop this radar loop. And what's going on there? Stop. Here we go. We're going to zoom on in. All right, so here's what we're going to do. We're going to give you the breakdown on what you can expect and all the things that's going to be possible with this storm. So right away, Karen, you're checking what tie I have on. This is the storm is brewing tie. There's no severe weather tonight, so there's no reason to wear the thunderstorm tie now because this is going to be daytime lightning and thunder for our area. Zach, you've been watching this storm closely. You've been doing updates on our live weather blog. Tell us, what do you think, man, what we got brewing on this storm system?
Well, we can see it out west. It's a line of severe storms, but the models, they've been pretty consistent. They're doing 2 things. They're trending towards an earlier start for us, and they're trending towards the instability not being very high.
Yeah.
And we need instability for severe weather. And we think that the instability is going to be lacking. And we need that. There are some other ingredients that are very high. The wind shear is very high.
Yeah.
We have a lot of lift, but we don't have the instability, and we need all 3 to have severe weather.
That's right. That's right. So we just pushed out that we're doing this live stream on our app, so you'll be able to see that. I'm excited it's storm season during the day, so we actually get to watch it. Exactly. You'll probably see some shelf cloud rolling in, and we still have the potential, though, for impacts. That's the thing with this storm system. Yeah. So we've got winds that could be gusting close to 40, 50 miles an hour, which is nearly severe strength. We've got the potential for some heavy rain that could cause hydroplaning. So that could be an issue with accidents on the roadways. And last but not least, we have the potential for a wintry mix. And I think that's looking
right.
I think that's looking very real. Wintry mix on Tuesday night into Wednesday morning. So let's show you here what we've got on live Doppler radar. So this is obviously a really fast satellite radar loop. Slow down. Here's a look at the storms that are tornado warned that are approaching Watonga. And by the way, Watonga, that's a city in Oklahoma that has a tornado museum, matter of fact. Well, and in fact, that's where they filmed the first Twister. I don't know if you knew that or not. Did not know that. Yeah. Look at southwest of Weatherford. You can see another tornado warning. That warning is going until approximately 11 o'clock. So it's just about ready to expire. Same with this one. This will probably be 11 o'clock as well, till 11:15 tornado warning. So those are those 2 cells. Now, we're going to show you what it's going to look like on the future track as we put it into motion and show you how it's going to evolve over time. So first of all, we got to give you the big picture. In case you missed our newscast, we got a lot going on, Zach. We got a lot going on. Here's the deal. Thunderstorms, you can bank on that tomorrow morning. There will be rain. There will be occasional lightning. There will be some gusty winds, maybe some hail, and possibly a very, very low-end tornado. The next thing is that we've got damaging winds that are going to be possible not only from this storm, but from what we call pressure gradient winds. Mm-hmm. This is an intense system. And wait till you see all the weather that it's bringing across the region and across the nation's midsection, where Tyler has wears pink. Well, you're not hearing pink in the background. That's because we're in the weather lab. Unless this is just a green screen and I'm at my house.
Could be.
You know. It's a good idea.
Yeah, why not? Just get an exact
Yeah,
copy.
I'll just get an exact background of the green screen.
People would never know.
I'll be like, I'm here at the weather lab slaving away. Meanwhile, you hear Pink in the background yelling.
That would be hilarious.
That would be funny. All right, going back to this. And another thing too, here's another thing. Here's a look at the next thing. Rain snow mix early Wednesday morning. So those are the 4 key headlines that we're having to do. So we are, by the way, thankful that instability is not returning. This is a good thing, folks. Unless you're storm chasing and you want a tornado that's out in the middle of nowhere, that's not going to hit anything. Chances are that doesn't happen. But we are basically thankful that instability will be lacking. But because the system is so strong, you've got to watch it closely. So that's the weather headlines. These are the main key takeaways from this system. And this, by the way, all happens tomorrow and into Wednesday morning. So here's a look at the severe weather risk, 6 a.m. to 2 p.m. That is our time window. 2 p.m. I think is a little late. I think it's all out of here by about noon. And then you'll notice here that it starts as early as 6 a.m. This is a much better idea on the timing. So we've got 6 a.m. to 8 a.m. as it starts to move into the western corridor of Northwest Arkansas. If you're asking about specific cities, every single square inch of the area is going to see storms, and I'll show you why. Then as we go into the I-49 corridor, Zach, 8 to 10 a.m. looks to be the most likely time for that, and then 10 a.m. to noon as it develops farther east into Northwest Arkansas. Here's a look at what's happening now, and here's a look at what happens on the future track. Notice how those storms, still intense, a little bit that happens popping up. And now at this time, 6 a.m., that storm system is knocking on our doorstep. So I think that looks pretty likely that we're going to see a line of storms coming in with a shelf cloud. Shelf cloud will probably be very well defined. It's going to be right around sunrise, so it's going to have that eerie color, that happens. Sunrise is a little before 7 a.m., isn't it? It's like 6:50. Yeah, take a look here at the time of the sunrise. I think 6:52 a.m.
6:42.
Oh, 6:42, even earlier. Nice. All right. So someone's asking about hot springs. You're going to see here as we push in. So we zoomed in a little bit too much, but we're going to show you here hot springs as well as I zoom out. But there's 7 a.m. You can see those storms knocking on our doorstep. And then as we go into 9 a.m., you can see the storms moving out. So yes, heavy rain, a short period of time for that heavy rain. That's why I'm not super concerned with widespread flooding. There could be some localized flooding, and there could be some ponding on the roadways just due to this heavy rain. But as far as river flooding, you're not going to see any of that. I really don't think, Zach. Now, as after that, this is where things get a little tricky. The storm starts to clear out. You might think the storm threat is over because it will clear out, and you're going to be like, whoa, wait a minute, what's going on? Everything kind of cleared out. Well, that is because the storm system has more precipitation that's ahead of it. And so after the noon hour, we've got a wind advisory that's in effect. And the wind advisory, by the way, goes until noon on Wednesday. So noon Tuesday to noon Wednesday, we're going to be watching that. And then you'll see unsecured objects could be blown around. Small tree limbs will be happening. And then, whoa, snow animation. Now, why is that? Well, after this round of isolated cells that will most likely be what are called low-topped. I don't know if they're supercells for us, but Zach, you might be storm chasing with Josh tomorrow. He's smiling. That's going to be in south central Missouri. I think that's going to be the best area for that. We get more southwesterly flow, so we're already starting to dry out. You can see some rain, though. That's looking very likely for the evening commute tomorrow. So you got rain in the morning commute, and then you got rain in the evening commute, too. Here's a look at that future track. As we go into the overnight hours, this is where the temperatures will really start to drop. And then you'll notice here that 11 o'clock in the evening, we're starting to see some wraparound precipitation. Now, this system is intense. and it's going to create a lot of precipitation in the cold conveyor belt. And I think this actually produces some accumulating snow, Zach.
Yeah, I think so too. And I actually just lowered the overnight lows for Tuesday night.
Yeah. So Tuesday night into Wednesday morning, before midnight, even Tuesday, we start to see some snow accumulation. Now, here's the thing. This is gone by the time we get up to about 7 a.m. Maybe some lingering flurries, but the accumulating snow will be gone. However, did you see the winds? I'm going to go back to this real quick. Look at those winds. I mean, those are sustained winds at 26. Maybe not quite blizzard criteria because it's got to be 35. Huh?
Check out the wind chill.
Yeah.
Yeah.
Yeah, we should.
Probably down to like 19, 18.
Yeah, we're going to look at that. Wind chill is going to be a factor, and that could lead to some blowing snow, and then that system's gone, but cloud cover is going to stick around. What do you have for a high on Wednesday?
I put it in the 40s, but that might be too warm.
We might want to drop that on the good old weather rate. In fact, I might upper 30s.
Yeah.
Yeah.
Even Drake Field, if we clear out, sun's out.
I don't know if it will though. This is such a big system.
Will?
Well, look, the HRRR is keeping those clouds around a little longer.
Maybe.
And 5 o'clock, you only have a little bit of sunlight left. Watch. This will actually go a little bit longer. Oh yeah.
Does the graph clear us out? I'm sure that does a lot earlier.
Let's look.
Oh, yeah, a lot earlier. Gone. That's noontime.
41, 42, 45. Ooh, there is a big discrepancy.
See, that's kind of what I'm thinking, but there is that stout northwest wind.
Yeah.
But we should be in the mid 50s, so mid 40s. That is 10 degrees below. But if we have some little snow accumulation.
Yeah, I don't think we're going to have much of a snowpack. Flash freeze, probably not, because it doesn't drop down into the mid 20s. It only stays in the upper 20s.
And it probably won't be all that wet on the roads.
What is the biggest threat in the morning? Yeah, let's talk about that. Good question. Let's show you the latest severe weather risk. So this kind of breaks it down for you. This is a great graphic for social media. This is the day 2 convective outlook. So our main threats are going to be a chance of Zach and me is in the high category. All right, we'll take that back off. But here's a look at, again, you've got large hail, low end threat. Tornadoes, really close to 0. High winds, 70 miles per hour. And flooding, isolated. So really the main threat is going to be damaging wind potential up to 70 miles an hour. I think there could be some issues on the roadways if that snow comes down heavy enough. That's the thing that's interesting. The auto captioning says a wind chill of 1988.
Ooh, that's
we're gonna chill like it's 1988.
A
Yeah. What about hot springs? You asked about it. Let's go back to it. I kind of forgot about it. Sorry about that. Hot springs will see some storms, but let's see here what we got. So we're gonna zoom out just a little bit, and we'll zoom out again, and we'll show you. So there will be some storms in the hot springs area. Yeah, I'm gonna have to delete this here. There we go. Let's just go out wider view. So there you go. Hot Springs, see some storms around. I'm thinking 8, 9 o'clock in the morning. And yeah, so we're bringing that up. Delete all these. All right, so here you go. So there's Hot Springs, 8 a.m. And right around 9 a.m., 10 a.m., that storm system is going to come through. Now, the tornado potential isn't very great for that area, which is perfect. That's awesome. It's not very high. Marble, you know the deal, Brendan. It looks like it's coming into Marble probably around, I would say, 9 a.m. School drop-off is going to be a little interesting. Yes, it will. There's going to be storms, some gusty winds. There's going to be a lot of energy. But Let's talk about what's lacking with this system, Zach. Lacking with the system is the instability.
And that is key for severe weather.
Yeah. Let's start off with some of the longer range models. So, first of all, this is the instability on the European model. You can see there's definitely some instability off to the west. Then, as we move along in time, that kind of keeps it around a little bit more, doesn't it?
A little bit.
Yeah. But notice how it kind of drops off farther south. Then we get a little bit of a resurgence of the instability. But look at what happens in south central Missouri. I think there's going to be some cold core tornado potential. Let's look at the Cape for the GFS. So here's the GFS as this loads. And you'll notice the instability greater off to the west. And then you see it kind of building back up, but just really doesn't build up much. Just a little bit of instability. Let's look at the Cape on the HRRR. So a lot more, and then look at how it just disappears as it comes in. That's not favorable. But then look at the instability build back up over south central Missouri. And what's interesting about that is the instability in south central Missouri is almost all 0 to 3 kilometers. We're talking extremely low Cape. So the tornado potential is low, but it's not 0. And then you see it moving eastward. So if we let's look at some SIG-TOR stuff. This is the significant tornado parameter. You can see how it nudges up, but then it just disappears. And then it moves across Louisiana. I think New Orleans tomorrow afternoon is going to be interesting. Yeah, not really, though. Not really. The instability does stay around a little bit, but it starts to clear out. So Kenzie has a question here. You should be okay. 8 a.m., 9 a.m. I have an appointment in Fayetteville at 11:30. Oh, yeah, 11:30. That storm's going to be moving out. Robin says, good deal. All right. So, anyways, I'm going to take a look here at. All right. So, just joined. 1 p.m. tomorrow. I don't think it's raining tomorrow at 1 p.m. In fact, I think you're going to be surprised how clear it is. How could it be clear? Well, there's a thing called the dry slot, and I think the dry slot's going to move right overhead. And this is a large system, by the way. So let me show you this. Tuesday's massive storm system. Look at this thing. And if we look at it, you can see this area right here that's beginning to develop right in this region. So there's the upper level low. Here's the dry slot that's developing. Along the leading edge, we're getting thunderstorms. But look at that dry air that's wrapping around. And then we've got this part of the low that's going to bring a wraparound snow on the north side. So if we look, check out all these watches and warnings. This is an insane system, Zach. That looks like a bucket of spilled paint. So here's what we've got. We've got so many things on here. We still have some tornado warnings. So we have, first of all, I'll just click on them. This is a blizzard warning that's in effect for western Nebraska and southeastern Nebraska. You got a tornado watch, tornado warnings. You got severe thunderstorm warnings. You've got a wind advisory, like we mentioned. You've got high wind warnings and a high wind watch. You've got fire weather warnings that are in place. You've got marine warnings that are over the Gulf here. So gale warnings for ships. You've got winter storm warnings and a severe thunderstorm watch. So here's a winter storm warning right here. Winter weather advisory, winter storm warning. I mean, you name it, man. This system has a lot
Crazy
of
how
stuff.
just one system can cause all these different issues.
This is an intense system for sure. Let me show you the wind stream here and show you why our instability is lacking. So this will give you a great example of what's happening. So we'll take a look at what's happening right now. So notice there's the flow out of the south for all that tornado potential. If you look at our flow, it's kind of east-southeasterly, including in the river valley. Look at how the terrain really impacts the flow.
Yeah,
Isn't
it
that
sure
cool?
does.
It sure does.
It's kind of diverting the south winds to our west a little bit.
Yeah, and you know what that does? That is a lack of surface moisture. In fact, I showed this on the air tonight. This is a look at the surface map, and that warm front is basically to our west. And so, because it's to our west, we're not in what's called the true warm sector, but look at the triple point that's setting up. And that's where all the storms are the most tornadic, is in between the warm front and the dry line. And that's where your storms are really cranking up. So, what is a gale? A gale force wind in meteorological terms? It's a good question. I want to say it's about 50 miles per hour. I know that gale force winds you have, yeah. So basically, 47 to 54 is a gale force wind.
And it's a sustained wind.
Yeah. And that's approximately 34 to 47 knots. So that's a wind force of 8 on the Beaufort wind scale. So that's something interesting. Gale force winds. So gale warnings 39 miles an hour to 54. And that's kind of associated with the kind of gives you an idea of the strength of the winds. That's like tropical storm strength. Yes, there will be a shelf cloud. Yeah, I can. I was about to show the dew points, as a matter of fact. So if we look at the dew points, first of all, in the region, you'll get to see that it's coming up from the south, but it's taken the long way home for us. So here's the dew points regional. Now you see where that dry line is. We got 57 and 63, but our dew point is in the upper 40s. And if you look and see what this moisture does, the deeper the moisture, the darker the greens, the more fuel that you have. We're at 50 for the dew point, and we don't start climbing until the storms are already moving in. 54 is enough of a dew point where we have thunderstorms, but look at the deep green colors. The deep green is the deeper moisture. And then look at how it starts shading yellow in the Louisiana area. That's where the more significant tornado potential will be. And then look at that system just kill the moisture. So this is an early season meteorological spring, early season system that will be lacking deeper surface moisture, which happens. So let me compare area Cape and Oklahoma. That's a good idea. We should do that. Let's look at the Storm Prediction Center. We can look at what's called Mesoanalysis. And whoa,
zoom that in.
Man, that's big time zoomed in. All right, so we'll look at the Mesoanalysis, and we'll also look at some other stuff. Now, remember, when I'm doing this, I won't be able to see your comments. But Zach, you're going to be proud of me here, because guess what? I'm going to do.
Oh, let's go.
Stream Deck. Open share screen. We're going to go
you always
to
yell at me
window.
when I use that. You don't want me to open OBS with it.
No, I don't want you to open OBS, but we're already open OBS and everything's working good. So
that's funny.
Yell is a yeah, maybe. Okay. Anyways, so let's look at some surface analysis. We'll start off first of all with the instability. Absolutely none for us, but it's all nudging up into Oklahoma, which is why there's tornado warnings. We move along in time, that surface-based instability lags back, and by 11Z, it still isn't in our area. So that's not favorable. If we look at the wind shear, 0 to 1 kilometer storm relative velocity, guess what? We got that. I'd like to see how fast those clouds are moving overheads. I bet you they are just screaming. So the shear is impressive, but it's just lacking.
Look at the 850 winds.
You want to look at the 850? Let's check that out. Whoa, 55 knots. That's pretty strong. And then that gets up to 60 knots as it comes overhead. Look at the 925 winds out of the south-southeast. So there's south-southeast winds. I bet you those clouds are moving.
Yeah.
They are cruising. So here's the thing with QLCS tornadoes. We're going to look at the 0 to 3 kilometer bulk shear and 50 knots. That's pretty close to perpendicular to that storm, which is why there's a tornado warning with it. So let's go back to, oh no.
Oh, seriously?
So I have this setting where I didn't add it directly to the stage right away. Let's go back and do that all over again. I know. Can't see it.
Hey, Wyatt's on here.
Hey. All right. Back to the mesoanalysis. Man, we got to make sure we add that every time. Every time. All right. Back to the mesoanalysis. We'll show you the surface-based cape. Surface-based cape right here, non-existent. And if we move along in time, you can still see it just remains off to the west. So it doesn't really move in. So we looked at that. And then we looked at the 0 to 3 kilometer storm relative velocity. And that's off the charts. I mean, these winds are cranking up. Let's look at the 0 to 1 kilometer. Here's the 0 to 1 kilometer storm relative velocity. You can see how that cranks up before the storms roll in. So this right here is 11Z, which is 5 o'clock in the morning. So pretty intense storm relative helicity, SRH. Now, when we look at the winds, this is what Zach was wanting to look at, the 850 winds. That's about 60 knots, almost 55, 60 knots. Very strong south-southwesterly flow. The 925 analysis shows south-southeast, so there's a little veering with the winds with height, meaning they're rotating, the vectors are rotating clockwise. And then you look at 500, and we've got west-southwest. So now I want to look at we're caught up. We looked at everything that we did before when we were just on camera. And here is the 0 to 3 kilometer max theta E along with the 0 to 3 kilometer bulk shear. But we're gonna look at a different one here. This is the lowest 3 kilometer max mixed layer cape. And then you can see that's 50 knots out of the west-southwest. So you got 50 knots out of the west-southwest. We look at the surface to 3 kilometer mixed layer cape, and you can see it's pretty high off to the west, right on the leading edge of those storms. And if we put that into motion, you can see how that just kind of, it tries to make its way in. And so it's something that we'll have to watch tomorrow morning in case that builds up a little bit more than expected. And then what I wanted to do is show you this, the bulk shear with the 0 to 3 kilometer cape. This is the best one right here. So you can see we've got exactly perpendicular to the line. So now that you've seen all that, let's go back to Mega Doppler and we'll show you the part of the area of the storm that's tornadoing. Guess what? It's oriented from northwest to southeast. Remember that shear vector at 50 knots is coming in there? That is exactly perpendicular to it. So we'll bring that up full, kind of show you. There's your storm. There's your rotation. That's on the leading edge of the storm. Let's get a different radar site. Let's get BNX. We'll get a little bit better of a view. There you go. Watonga. Storm's going right over Watonga. Wow, that looks like a tornado right there.
CC.
No CC drop. Right in the attenuation area. Look at that. Do you see all the attenuation?
Oh yeah.
This is tough. When the storm is parallel to the radar beam, which is exactly what it is, that's where you get the worst. That's where you get the worst readings for QLCS tornado potential. All right, so that's that. So that shows you the storm is pretty impressive. Let's answer some questions here. That's Tuesday, Wednesday, or Tuesday. What? That's right now. That was actually happening right now, and everything that we were looking at is happening right now. Wyatt says, hi, Zach.
Wyatt, how's it going?
Yeah.
Shout out to Wyatt.
I cannot tell the difference in spotting a shelf cloud and a wall cloud.
Well,
oh, Zach.
Do we have a graphic?
Do you have it up here from your Storm Spotter training class?
Yeah, I mean,
I don't think we do have.
we don't.
I don't think I do have a graphic for this. I do on my presentation, but not on this. Nope.
Well, tomorrow we'll be seeing a shelf cloud.
And what's the difference?
Wall cloud supercell.
Yeah, but sometimes you can have shelf clouds on there too.
Well, shelf cloud, kind of looks like a shelf. Has to do with cold outflow coming in, and when you see that, that's when you feel the winds, and usually not raining. Usually the rain is behind it.
No, that's not going to work, Will. So let me tell you this. The difference between a shelf cloud and a wall cloud. There's three characteristics. Number one, a wall cloud, we're not going to talk about those, but basically a wall cloud is a lowering that is defined that maintains its position with respect to the precipitation area, meaning it's kind of separate from the precipitation area, unless it's a high precipitation supercell. Another thing is that it slopes towards the rainfall, right? A wall cloud has a slope that's towards the rainfall and the core that's out ahead of it. So you have essentially that. And then the third thing is that it's basically not a super elongated cloud. You might think a wall, like a wall of clouds, is coming in, but this is actually like a different thing in terms of a shelf cloud. So a shelf cloud is kind of a very large, wide cloud that's moving in. There's precipitation that's behind the shelf cloud, so it indicates outflow, right? And it is sloping down and away from the precipitation as you're looking at it. So that's the characteristics of a shelf cloud, and there's no rotation. So Michelle is asking, all right, what time is it supposed to hit? It's a good question. We haven't answered that yet. Let's show you here. Yeah, and that's another good thing. Wall cloud is associated with the updraft of the storm, whereas a shelf cloud is associated with the outflow. Boom. That answers that really pretty quick. Here's a look at the precipitation timeline. This is kind of tricky, but there's a chance of a few isolated showers in the morning. But as you can see, the most likely time for storms will be around 8 o'clock in the morning. It's pretty quick because it moves out and it drops off pretty dramatically, and then it bumps back up during the early afternoon as that next round of rain comes in. And then look at the wraparound snow that develops Wednesday night into Thursday morning. I think this is great, Zach. Yeah, you can't have a computer model do this.
I was thinking about making that 60-70 for the wraparound snow.
Yeah. So Bradley's talking about the March 30th, 2022 had storm activity like they're calling for overnight. We got a sudden spike in 0 to 3 kilometer instability, and then bam, strong tornado. True. That's why we can't let down our guard. You're very, very correct on that. I will say that looked a little bit different than what this does. You could see that moisture surge as it was racing in. But I was concerned about March 30th because I did a live stream until 2 in the morning that morning. But I'm not exactly sold on this being like that. That doesn't mean you can't see a tornado. That's why we're not letting down our guard. Did I ever show that risk graphic? Yeah, I did.
Yeah. That was a while ago.
Yeah. Let's do it again, huh?
Show it again.
All right. My weather needs meds. This is going to be nuts. I know. There's like so much happening. All right. So here's a look at the severe weather risk. There's the hazards. Let's look at the individual threats on this one. So we'll start off with the tornado potential. You'll notice that it's fairly low for us, very low. Then it goes to low, and then look at the hatched area for tornadoes. All the way down. I think they should drop that down to New Orleans personally, but we'll see. Here's the wind threat, and you can see pretty intense storms that are coming tomorrow. This is where the greater instability is farther south. So that makes sense. But notice how we have more of a damaging wind threat over us. And then large hail, not super widespread. Then, as we go to the precipitation outlook, there's a chance for some excessive rainfall that could develop as well. Monica, not a great idea. And I'll show you why. There's going to be storms everywhere, honestly. Let's show you the newest HRRR, and we'll kind of step through this as we go hour by hour. So let's show you here. This is what we've got. There's 7 a.m., there's 8 a.m., 9 a.m. Look at how things just erupt. So the shelf cloud will probably be pretty impressive in Oklahoma, and then it'll start falling apart as it makes its way into northwest Arkansas. But still, you can see some of those stronger storms. Now, this is that break right here. Totally clear during the early afternoon, only to see more clouds start to develop pretty rapidly because the temperatures are so cold aloft. And then that system lifts northward. Here's the wraparound snow, and then the system kind of moves out. What happened to the Texas Tech model? You know, it's not great for winter weather, I could tell you that. But for severe weather, there's some advantages of it. So let's check it out here, and we'll look at it. Shall we? Still going. The Rufus model is trash. That's no longer happening. But here, let me show this. So here's the Texas Tech model. Let's do reflectivity and updraft helicity. So, wow, look at that. Going nuts there, huh?
Yeah.
And this is the current run. Yep. But then watch how it just kind of falls apart as it makes its way into northwest Arkansas.
Ooh, yeah. Legit at the state line.
Bam. Just dies. Because it outraces that instability. Look at that.
To our south, though, it doesn't.
Man, it does not.
Strengthens.
Wow.
Keep going to the afternoon. See what happens.
No helicity tracks.
No.
Let's look at the convective, and then let's look at the 0 to 1 kilometer EHI. So watch, this is going to ramp up tonight. Then it dies. Look at how it dies as it comes in.
Goodbye.
Wow. That is just amazing. That's why here's updraft helicity. Just doesn't really happen here. I am thankful for that. Here's the significant tornado parameter. So tonight, very impressive out west, which is what's happening. Then it dies, and then look at how it just absolutely dies right before it gets here. And then here's the problem. There is no... Oh, let's look at the wind gusts here. This ought to be good. Golly, man, those winds are going to crank up. And then look at that. Those are pretty strong winds, nearly 60. Wow, that's 66 miles an hour. No, knots. That's pretty strong. And then look at the wraparound that develops winds. My goodness. That's insane. That is one heck of a wind. And then look at the wind just kind of die down. And let's look at one more thing here. How about 0 to 3 kilometer mixed layer cape? All right, so here you go. Watch this. This really ramps up, I bet you, in south central Missouri, Zach. Right now. Look at that.
Oh, yeah, it's got a lot.
Right there. And that is where your better tornado potential will be, because look, we'll go to wind speed. Watch, you're going to have southeasterly flow. You see that? East-southeasterly flow. Whereas we have southwest. Look at that. See that? Southeast, southwest. So if we were to look at that and go to layer Convective. Look at a 0 to 1 kilometer storm relativity. Can't you just keep on the same time? Look at that.
What's the day 2 outlook for them?
They don't really have much.
Is it marginal?
Because it's a cold core. Here, I'll stop sharing and I'll show you here. All right, let's go back to this. Yep, that's exactly right. Strong winds and Rogers. Rain total will probably be around an inch and a half, honestly, Mandy. So let's go back to, let's look at, you want to look at the risk, right?
Yeah.
Yeah, marginal. But I even asked on the weather service, like they have marginal all the way up there, and then you go to tornado, and of course they have it very low. Cold core timing is going to be around 3, 4 o'clock in the afternoon. Peak heating. Yeah, a lot going on. That's for sure. All right, let's. Oh yeah, sure will. Yeah, we had our storm spotter team meeting tonight. I know you had to do some work, Alex, and we missed you. But we had a great meeting, and Josh will keep you updated. By the way, that tornado warning is gone now. That's approaching Hennessy. Not even tornado warn now. It looks like it's kind of running out ahead of the instability. So I think the reason the instability dies is because it just doesn't have the trajectory for the deeper moisture return. Because we have more of a southeasterly wind. Watch, I'll show you. This will show the winds along with the storm system. It actually does a pretty good job. So let's go back. See how the winds are out of the east-southeast, Brendan? So if we move along, east-southeast, and that brings in that drier air. So, and you'll notice the temperatures are warmer too. So it's just some ingredients are lacking. Will we let our guard down? Absolutely not. We'll still watch it closely. So, how about this? Will the rain and thunderstorms hit our area on Texoma area, Colbert? Yeah, it will. You'll get rain. There's no doubt about that. We're definitely getting some rain. Aha! I have not contacted you. Oh, you already have a subscription. Okay, I didn't know about that. But I already have a subscription for it, so I could pass along to someone who doesn't have it yet. Yes, that sounds great. Weather Call Next Gen is amazing. The new Outlook is coming out at midnight, and so we'll wait. We'll stay up for it. You'll see the new Outlook here before we go. Taking on new season storm spotters, absolutely, and most of them were storm spotters that we've had. Do you think we get downgraded? Well, do you think we get downgraded to a marginal? We're already in a marginal, actually. Well, I take that back. No, because of damaging wind potential. I don't think so because of the damaging wind potential. So here's a look at the risk. And again, we'll watch it closely. Are the mountains a reason severe weather dies at the state line? You saw the way the wind flow is perturbed and affected by the terrain. That does have something to do with it because you need moisture, you need instability in order for storms to develop. And if that's not in place as the storms move in, typically it doesn't develop. So we do need to get the 8-ball out. 8-ball's kind of pesky.
Yeah, so it's probably not affecting the storm itself, but it's affecting the environment ahead of it.
Yeah. So we will have rain and damaging winds in Springdale. The active severe weather season will definitely be an issue. Huh. Yeah, that's going to be pretty soon because there's already pollen that's flying around. Shayla Ritchie. Hey, girl. Hey, it sounds like you know someone there. That's cool. All right. Back to, let's see here. Mega Doppler has a thunderstorm now that is considerable, and that's in the considerable area. Someone wanted me to show the QLCS graphic again. What do you think?
Let's go for it.
think this is a good time to show it. Let me know if you guys want to see that QLCS graphic. I just want to see the 8-ball. Jeffrey's like Fayetteville Fizzle. And that's the thing, we're actually calling for somewhat of this storm system to fizzle out. But remember, you've got 3 sides of this system. And I think all 3 sides are going to come to fruition. The potential for heavy gusty winds and rain. And I mean, look at this system here. So it's just massive. Look at what's churning up on the north side of this system. Man, what a large, massive system. Now, here's what happens when we look at the vorticity. By the way, we changed this map, but it gives you an idea of all the little spins that are in the atmosphere. So this already is advancing eastward. But look, you've got 2 areas of circulation that are possible. There we go. Oh, can't do that. Just go out one frame. There we go. Pause it. So you got, look at how fast it's evolving. So you got this system down here. You got this system to the north. This is the one that rounds the base of the trough. Watch. Blink and you miss it. Look at all that energy that's out ahead of it. So there's the storms that are out ahead of this. And then you see it kind of moving eastward and then moving over our area. So that thing is cranking big time. We're down to a 988 low. Let's check that out. Let's go back here to the Mesoanalysis tool. So we'll do this. We'll share this tab instead. We'll go to surface. We'll go to mean pressure winds. And let's go to change the sector. Let's do the central section. 988. Wow. Look at that low, man. But look at our surface winds. They're just weak sauce here. So if we look at the dew points, let me make sure we're on this. Okay, we are. Sometimes that doesn't happen. So let's show you here as we look at the dew points. There's the deeper moisture, and look, that just doesn't come in. Storms outrace the moisture gradient because of the trajectory. And here's the reason. Look at the trajectory of the low. The low is in western Kansas still. So you got an east-southeasterly wind component. So that's not going to be very favorable. Shear is off the charts. Super impressive. You can see the EHI is just, there's so many things that are there now, but just won't be here when it moves in. What the scallop does weak sauce mean?
Weak sauce?
Yeah, weak sauce.
It's kind of like a mild, like this place.
No. Yeah. D-Cape isn't super impressive. No, because you got to remember that you're not going to have extreme instability, but we could show you what the D-Cape is expected to be, but it's not going to be super impressive. At least for us, it won't be. See it dropping off, but it's got maybe 1,200 to our southwest, but it kind of drops off over us. So I'll show you as we bring in pivotal weather here. And I know that's not showing up on there, but I will show you here in just a second. So let's go to, let's just do a sounding here. Let's zoom in. I wish you could tell it what to start off with, So it doesn't do that. So severe weather, let's do mostly unstable Cape. Let's move along in time here. Forecast loop. Yeah. So we're going to go back here. I'm going to share this tab instead. Okay, so here's the instability. We click on this, and you'll see D-Cape is like pretty low. 6, -6. That's garbage because there's not very warm temperatures aloft. So if we go back in time a little bit, right now, the D Cape is a little more impressive. Right here, 931. That's a little more impressive on the D Cape. Look at that shear profile, too. Pretty impressive on that. But yeah, we'll just hang out here and we'll wait for the new day one convective outlook, Zach.
Should be out probably 20 minutes.
Yeah, maybe a little bit more. All right, let's do some 8-ball here. What do you think?
All right. Anybody have any questions?
What time should you leave? Oh, QLCS graphic. Shayla wants to see it. No cookies tomorrow. I know that's a bummer. Some ingredients are missing. I think we see a severe thunderstorm watch. Maybe it might not even be issued. Honestly, we'll have to see.
Probably for like our 8-air Delaware County.
Yeah. Oh ho ho! Not only did we have Baja Blast,
Oh,
I brought my whole freezy machine.
got a little nuts.
Yeah. All right. You want me to do it? You
Yeah.
want to do it? All right, 8-ball. Let's see what you got. Is the 0 to 3 kilometer Cape underestimated for our area tomorrow morning?
That's a big one. Oh, all right.
Cannot predict now, it says. Well,
Interesting.
thanks a lot, 8-ball. I think it's starting to get more and more worthless.
At least just being honest.
Yeah, that's right. All right. Well, we'll ask you again. Will there be a tornado warning in our weather coverage area? And it says, I don't know. I shook it up so much. There's bubbles everywhere.
Yeah, that happened to me one time.
Don't count on it.
All right.
Don't count on it. Oh, snow accumulation. Good question.
Yeah.
Marilyn asks, oh, magic 8-ball that's worthless and can't get anything right lately.
I'll be nice to it.
All right.
Come on.
Sorry, 8-ball. You're good. In fact, you're probably the only reason we have viewers.
Probably.
All right. Will there be accumulating snow in Northwest Arkansas Wednesday morning? Oh, golly.
Wednesday.
Yes.
Wednesday morning.
Yeah, Wednesday morning.
How about Tuesday night?
Well, it's after midnight. It'd be Wednesday morning. And maybe Tuesday night.
Maybe.
It says yes.
Yeah.
Will there be, how about this one? Will there be issues on the roadways Wednesday morning for the commute? Without a doubt.
All right.
Wow, that wasn't even a question.
Well, it is a strong system.
Yeah. All right. This is a good thing. What did I miss? You missed us just clowning around for about an hour. 57 minutes. No, honestly, we're going through some science. We're going through some timing. We did a lot. But let's give a little recap, shall we? Let's start off, first of all, with what you need to know. If you're just joining, we'll kind of go through our little spiel. Oh, Alex, I like that question. Let's do that. Will there be a blizzard warning in Northwest Arkansas? I know Alex is kind of rooting for that or just thinking that might happen. And it's not out of the question, honestly. Will there be a blizzard warning for Northwest Arkansas for our weather counties? Most likely.
Oh, first time in history?
First time in history for Northwest Arkansas. Oh, man. All right. This is what you're missing. So, first of all, our weather headlines. Storms are going to happen tomorrow morning. There's just no question about it. We know at least there'll be rain. Some of that will be heavy. Lightning could be a possibility. I think we'll see some lightning. But I do think the storms will be weakening as they move in because of the lack of low-level instability. Main threat's going to be damaging winds. Intense gusty winds Tuesday afternoon into Wednesday morning. That's going to be from the pressure gradient and the storm system. And then late Tuesday night before midnight, into Wednesday morning, about 5, 6 a.m., we got the potential for a rain-snow mixture with the potential for some heavy snowfall rates that come down. Maybe accumulation will be limited. We'll show you that. So here's a look at the day 2 convective outlook. Damaging winds, large hail, the main threat. Here's the timing, as we'll take you through the future track models. 6 a.m. to 8 a.m., 8 a.m. to 10 a.m. is the lighter blue, and then the darker blue is 10 a.m. to noon. So here's a look at the future track timing. Notice that line making its way eastward. We'll start zooming in here at 6 a.m. as we come into northwest Arkansas, 7 a.m., 8, 9 o'clock in the morning. So pretty quick moving system, but man, the winds are going to be crazy tomorrow. Here's a look at the future track 4-kilometer graph. After the storm system moves through, we get a break during the afternoon, only to ramp back up as we go into Tuesday evening. That doesn't show as much, but look at how the low is to the north of us. So that's where your supercells are going to be, I think. And then that snow starts to wrap around. Now, this will be a pretty intense band, I think. So that is that's that model. Don't forget, we've got a wind advisory that's in effect, and that includes northwest Arkansas. In fact, look at the size of this wind advisory. My goodness. That's about like the size of Alaska and bigger.
Yeah.
That thing is huge. That's like twice the size of Texas. And you don't normally see that, the entire area under a wind advisory. That shows you these storms, the winds are going to be crazy, not from necessarily the storms alone, but from the pressure gradient winds. Then, as we go into our Tuesday night, watch this wraparound snow that starts to develop as that colder air starts pouring in. And there you have it. In the early morning hours on Wednesday, snow accumulation not out of the question. Here's a look at the accumulation that's expected, and we'll look at some other models. It'll be close to an inch in some spots. Let's look at the 4-panel snow accumulations. I think I deleted them too. Nope, I didn't. Knowing good and well, I probably needed to keep them. So the graph, about a ½ inch to an inch. The European doesn't show much. The graph, the GFS, it's got a little bit of snow. And the NAM, whoa. For Southwest Missouri,
is that like 4 inches?
That's not out of the question, man. That's a lot.
That's getting up there.
It's a potential that this system could be extremely dynamic. So if we look at the current conditions, there's no more tornado warnings. There is a tornado watch that's until 5 a.m. and severe thunderstorm warnings, including a considerable severe thunderstorm warning, but a tornado watch until 5 a.m. That's out west. Obviously, it doesn't come in here. So should we take our kids to school around 7 a.m. or wait?
Yeah, that's the thing.
I think that's a good idea to go a little earlier, because the later you get, the more likely those storms will be rolling in.
Yeah.
You have a better chance of missing them if you get in there early rather than later. And on top of that, rain will be heavy enough where there could be some issues with heavy downpours. Here, I'll show you a different model. We haven't looked at this. We haven't given them the 3-kilometer NAM any love, have we?
Shows a lot of snow.
So here's the 3-kilometer NAM. There's the precipitation. Look at just kind of thunderstorms, nothing super major. It does. It dies out. Additional storms, and then here comes that wraparound snow. And that moves out just about 7 a.m.
It's not as cold as the HRRR.
No. And then it's gone. Now, what does it show for highs? 45. Yeah, I think the HRRR is a little cold, a little too cold. Now, here's the wind. Here's the rain totals. This is where the graph has about an inch and a half, which I think is pretty realistic. European, a little less. I think it's a little too little. There's the GFS. That's inch and a half in Fayetteville, and the NAM has about an inch. So an inch and a half, I think, is a pretty good bet.
Yeah, initially over the weekend, early in the weekend, the models were showing 1 to 1.5 inches of rain, and then Sunday they kind of backed off, doing like a half inch to 1 inch, but now they're kind of back on board,
Yeah.
showing some heavier rain.
Let's take a look here at the graph winds, the wind gusts.
It's got one big severe storm warning out in Oklahoma.
No, just basically covers the entire line.
Yeah.
For 60-mile-an-hour winds. Okay, here is oh boy. Here's the wind gust for the graph. We'll load this up. So here's a look at what we got now. And then watch these reds showing up. Yeah, it shows about 30, 40-mile-an-hour winds. Then it breaks off, slows down during the late morning. That makes sense as the low comes overhead. And I'll look at the pressure gradient really crank up here. So right here. Overnight, that's when the snow's coming down. Yeah, that's gusts over 40. And then they start dying off. But man, hey, wind chill, right? Didn't we want to look at wind chill?
Yeah. I saw Bradley's comment about the flying trash can.
Yeah.
It's going to be an issue.
Oh.
Lower 20s, upper teens.
Upper teens.
Yep.
Upper teens.
So if you thought we were done with the winter, not quite yet. Phil might have been right.
Phil.
He's still back there.
He's still smiling.
Yeah. He does not stop smiling.
All right. QLCS graphic. Ready? Let's do it, huh?
Let's go for it.
And then by the time I'm done explaining that, the new risk will be out.
This is a really good educational tool, especially with what we're going to be seeing tomorrow morning.
Yep. But there's a reason why we're going to be lacking some different ingredients. So first of all, let me take you through what's happening right now with the QLCS. And then you're going to get to see what exactly that means. So, we'll go to Mega Doppler. Okay, so here's Mega Doppler, and there's the line of storms. And you can kind of see how they're slowly falling apart. There was a window of opportunity there. And then we kind of go north, and that storm by Perry is looking a little more interesting.
Yeah, that's pretty strong.
All right, look at the storm relative velocity. Yeah, not really showing much in terms of rotation. Okay, so real quick, I want to show the Mesoanalysis tool. We'll go back to this, start sharing the tab, and we're going to look at two things. We're going to look at the 0 to 3 kilometer bulk shear and the 0 to 3 kilometer cape. So first of all, you're going to notice is the bulk shear has values around 50, but look at how the storms are starting to outrun or outrace their low-level instability. Do you see that? 0 to 3 kilometer low-level cape. It was there, and then it's kind of shifting eastward. And we're talking winds in excess of 30, 35 knots. So we have enough bulk shear. But what does that mean exactly? Well, that's why it's time to step into my office as I give you the QLCS tornado graphic. Make sure people have this on there, which I bet you they weren't seeing that. Real quick. It's tough to do this sometimes. So here's the 0 to 3 kilometer cape. There's the 0 to 3 kilometer bulk shear that shows 50 knots. There's 45. There's 45. There's 40. So we know that the amount of shear is sufficient for tornado potential. We know the 0 to 3 kilometer cape is there. That's why they had tornado potential. But now let's take a look here at just how this evolves and what this means. So we have our QLCS. And a QLCS stands for a quasi-linear convective system, which basically means a broken line of storms. There are three ingredients that you look for to determine tornado potential. The first is you look for a balanced or slightly shear dominant area along the UDCZ. This is called the updraft downdraft convergence zone. The updraft downdraft convergence zone is basically the leading edge of the storm, or sometimes the outflow, where you know that you have inflow and outflow of the storm that are combining. There are three regions within this storm, or within the QLCS, that you are looking for tornado potential. Cold pool dominant, not likely for tornadoes, the least likely area. Shear dominant area, not as likely for tornadoes, but possible. And then you've got the balanced region, which is kind of right in the middle. Not always, but in this case, it's in the middle of the line. So what does that UDCZ look like when you bring it down to the surface? There it is. It's on the basically the leading edge of the line. The next thing that you want to do is you want to look for find the line normal, a 0 to 3 kilometer bulk shear. So what is this 0 to 3 kilometer bulk shear that's greater than or equal to 30 knots? Well, we know that that's greater than equal to 30 knots tonight. But what that is essentially the winds. So think of it this way. You've got westerly winds aloft, weaker at the surface, stronger as you get up into the atmosphere. If you get above 3 kilometers or you get to 3 kilometers, you'll notice that if I put a pinwheel in this, because of that stronger wind at the top of the shear, that would rotate that in a clockwise direction. Well, guess what? This is known as the environmental vorticity, known as the shear rotor. So this is the shear rotor on the leading edge of your storm. At the same time, remember how I was talking about cold pool dominant, shear dominant, and balanced? Well, the cold pool is rain-cooled air that's descending out away from the thunderstorm. By the way, Zach, this would be a shelf cloud that's along the leading edge of the line, because the rain is flowing out and the cloud would be sloping down and away from the precipitation. So this indicates outflow. And along that cold pool, as that surges out, there is a counterclockwise spin or rotation with this. So this is known as the cold pool rotor and the environmental shear rotor. Now, if a thunderstorm were to develop in this, because of the cold pool is stronger than the environmental shear, it would take this storm and kind of tilt it back to the west, which is exactly why you see a gust front that's out ahead of the line. So the cold pool dominant means that the system's cold pool rotor is stronger. It's spinning faster than the shear rotor. So if I were to put a balloon in here, it would get sucked back to the west, essentially. So the updrafts tend to be weaker and rearward leaning, and tornado development not quite as likely. All right, so you get the idea that that is the environmental vorticity for the shear rotor. Now we'll take a look at the next area, which is the shear dominant region. I see there's no comments right now because people are just concentrating,
just locked
in on what I'm talking about. So the shear dominant area is a little bit different. Now you've got the storm that's kind of forward leaning, and the UDCZ is kind of on the backside of the storm. So now we got the cold pool that's a little weaker than the shear rotor. So the shear rotor is spinning faster. The cold pool rotor is spinning slower. So as the cold pool comes in, it gets lifted up to the basically not quite up and over it, but it stays out to the west. And when you get thunderstorms, guess what? They're going to be forward leaning. So those are weaker because they're slightly forward leaning, and you can still get tornado potential, but it's probably not as likely. And so this is when the shear rotor spins faster than the cold pool rotor. All right, so now that we've got those two areas that are pegged, let's look at the balanced region. And in the balance region, the ingredient number 3, you want to look for surges or bows along the line of thunderstorms. And here's why, because there's times when that balance will be not there, but a surge happens, which catches the storm up to the UDCZ. So now you know that you've got updraft, downdraft interaction right next to each other. So let's take and examine the balanced region. So in the balanced region, you've got, guess what? A cold pool rotor and a shear rotor that are spinning about the same speed. So we know the 30 knots is magnitude is great enough. We know the cold pool is going to be strong, but not too strong. And so what happens with this is as that cold pool comes in, guess what? It gets lifted straight vertical. This is known as constructive interference because this is kind of like, think of it this way, Zach. We were watching the combine, and while they had human quarterbacks that were throwing the football, sometimes with catching practice, you have those spinning rotors. You put a football in there, what happens?
Goes straight as an arrow.
Poof, shoots out straight as an arrow. It's because both of those rotors are spinning the same speed. So that is going to create lift. So when you have this horizontal vorticity tube that's coming down from the rear flank, the rear inflow jet of the QLCS, which is indicative of a reflectivity drop. We'll show you that on the radar. Don't see it right now, but you got to have 0 to 3 kilometer cape. Now, 0 to 3 kilometer cape is low level instability. That's where your air is buoyant and it could rise. So that streamwise vorticity, if there's enough 0 to 3 kilometer cape, will get lifted into the vertical. As that storm stretches out, it creates what's called tilting and stretching, which speeds up the spin. And then you're going to notice here that that's where your tornado potential will be. So the balanced regime is where you have the system's cold pool and the shear rotor that are spinning the same speed. The updrafts tend to be vertically deep and upright, and you have constructive interference maximized. So this is your most likely area for tornadoes. And guess what, Zach? Over time, that's exactly what you got. Tornado dropping down. And notice how there's rain around it. So typically, when you have a balanced region, you've got the storm, the tornado that's pretty close to the rain core. So they're typically rain-wrapped tornadoes. And that is QLCS tornado research and basically more information about that. So again, the 3 ingredients, look for the balance or slightly shear dominant UDCZ areas. Look for that line normal 0 to 3 kilometer bulk shear greater than or equal to 30 knots along the UDCZ. And then look for surges or bows along the line of thunderstorms. Right now, we're not getting much surges or bows. If we go to Mega Doppler, you can see this line is kind of oriented northeast to southwest. Don't see much surging. There's not really a whole lot of rotation on this. There's a few little spins here. Look at this one right here. That's west of Kingfisher. So that is a little bit of a spin. And if we look, hey, look at that, a descending reflectivity core that's kind of running more north to south. And there's definitely rotation there. So that could be an area that, in fact, prompts tornado potential. And notice how there's no warning on it. So that's what we could be looking at right there. All right. I know, Edward. I see Edward saying 5 minutes, 4 minutes, 3 minutes, 2 minutes, 1 minute.
Would you say that you need to have the descending reflectivity core to ingest the streamwise vorticity?
I do believe so, yes. Yep.
So if you don't have that descending reflectivity core, there won't be a tornado?
I don't think so, no, because you're not able to surge that streamwise vorticity into the storm. But I wouldn't doubt if this gets tornado warned here. That's definitely a little bit of a spin up there. And yeah, set that storm motion for the warning. It's already there. Spectrum width shows the circulation. If we look at the chat. Oh, wait, hold on. Storm relative. There it is. Look, there's another area of rotation too that's popping up there as well. But this is why these QLCSs are just so tough to discern. but that could be a precursor to it. And so there's that spin. We look at the vorticity, the rotation. That's pretty persistent, and that's right along the leading edge of the line. So we'll have to see if a tornado warning gets issued on that. That looks interesting. Raindrops in East Springdale. Well, how about that, Zach? New risk is out. So let's check it out. No changes at all to it. In fact, it looks like they just carbon copied the forecast here. Let's see what we got for day one tornado. Oh, they nudged that 5% a little bit north, didn't they? Well, no, I think this is the exact same.
Yeah, it looks similar.
I think it's about the exact same. Day one wind, exact same. Hail, exact same. Wonder if they did anything on the cold core setup. Nope, they don't have anything on the cold core setup. And wind, boy, they didn't change a single thing. That looks exactly the same. So that's it. No changes at all to the risk. And I'm not surprised about that. All right. New day one is out. Oh, thank you, Shayla. Appreciate it. Yeah, you'll be able to sleep all morning long. You'll be able to sleep all the way till about 7 a.m. Setting your alarm for 6 a.m. I just don't think there's anything before that. Let's look at the HRRR that is updates every hour.
5 a.m.
So here's a look at 5 a.m. You're going to be waking up with wind, and that's about it. So, hey, y'all from Northwest Arkansas. Here's a look at I like that profile name. That was cool.
Yeah.
There's a look at the storm. See, look, 8, 9 o'clock. So 8 o'clock in the morning, there's the line that comes in, and then it's gone. And then here's that wraparound, arcing supercells, but that doesn't clear it out very much now, does it? Let me zoom out here a little bit. Yeah. That's it. And then there's the wraparound snow. Look at all that that's coming south.
Wow.
Wow.
It's pretty heavy up there.
Whoa.
Those dark blues.
Yeah, that is a lot.
There's a lot of heavy snow up there.
Yep.
Big system. Impressive.
Yeah, for sure. All right. Well, I think we wrap it up here. What do you think? You're at your hotel.
When does the WPC release their latest?
That's going to be in
rainfall.
the morning. That's
Yeah.
going to be in the morning. Mm-hmm. The WPC does have a little bit of stuff. You know what we could do? 7 day. Let's end it on the 7 day forecast. So here's our 7 day. Oh, what? Let me go back to this. Come on. Might not want to reboot the computers too for
Yeah, we should.
Josh in the morning. So here's the 7 day forecast. First 5 days. There's a lot going on there. You got Windy Willie on there, Zach.
Blowing away.
Yeah, Windy Willie, and rightfully so. His winds are going to be crazy strong. I can't hear the wind at all right now. It's pretty dead quiet in here in the studio. But some severe storms that are going to be possible. 100% chance of rain. Very gusty winds. Temperatures in the mid 60s. Now, too late on adjusting weather rate for Wednesday, but
I still think 40s is good.
yeah,
Don't you? I mean, they're just
maybe
Drakefield.
42.
Drakefield, yeah, probably lower 40s.
That's all right. Here's Thursday and Friday. We get back up into the 50s and 60s. So even if it does snow Wednesday morning, it's not going to be a lot. There's a look at stays active. Don't forget daylight saving time starts. Where you flip that clock ahead an hour.
Ooh, coming up.
I like it. It stays lighter later. It's a sign of a change,
I like it
change
too.
in the guard.
I like it too.
I don't like how the SPC is an hour later. I don't like how the models are an hour later. That's a bummer out of all that. Here's a look at the River Valley forecast. some severe, not necessarily seeing a wintry mix. And that's basically it. So yes, to answer your question, we will be going live if the storms get bad tomorrow or today now at this point, since it is Tuesday. So we've got this. Download our free Weather Authority app. If you haven't done it already, alert notifications, video forecast updates. Josh will be doing live streaming. He'll push out that he's doing live streaming if it's really bad. If it's not, if it's garden variety thunderstorms, he'll be on the air at the time. So he doesn't necessarily need to stream at the same time. But I think he'll be doing that anyways. So a lot of impacts with this system that are going to be possible. Don't forget, it's not just severe. It's gusty winds. It's snowfall that happens on early Wednesday morning and a lot of other stuff.
Yeah, the impacts from this will begin tomorrow morning and they'll be felt for 24 hours.
Yeah. And then that system moves out and then we got quiet. So I love that.
Yeah.
All right, guys. Well, we will catch you later. We'll take a look at the latest tomorrow, today, later. I don't know.
I don't even know anymore.
Yeah, I know. It's crazy.
Tuesday. It's Tuesday.
Yeah, I don't know, Antonio, in Smyrna, Tennessee. I think you're going to see storms there as well.
I don't know where that is, Smyrna.
Yeah, I don't either, to be honest with you.
Where is that?
Well, let's check it out. It is southeast of Nashville. Hey, you know where that is. It's close to your brother's stomping grounds. Sure well, actually, he's west of Tennessee, right?
He's north.
Oh, he's north?
Yeah, he moved out of Hendersonville.
What? Did he?
Yeah.
Where is he at now?
White House.
Oh. He's in the White House? How about
That's near the town.
All right. Let's take a look here for you. This will be the last thing we do. But yeah, over in southeast Nashville. Let's do that. Let's go to the wide view. Yeah. All right, stand by here. I got to remove some scene cameras here. All right, so, wow, there's the line coming through, and not a whole lot of instability. So there's Nashville. Look at those winds, though. Man. Oh, there you go. There's Smyrna. So it looks like early to late afternoon, you got some storms rolling in. But I don't even think you're in the severe weather risk, honestly. Let's look real fast. Yeah, marginal. And tornado potential, non-existent, wind and hail. It's mainly a wind potential. It'll be definitely removed from all the instability. Wonder what the moving HRRR looks like farther. It's always zooming in. Let's get rid of that. Wind's starting to pick up in Bentonville, huh? I haven't even been outside all day. You know that?
They're cooped up inside.
Take a look at the supercells down south here. There you go. Yeah, some isolated supercells. You see that? Oh, that's a pretty bad one right there. Yeah, elongated. That shows you there's a lot of shear. Look at that. Oh, come on. Yeah. All right. Oh, cool. Laverne lives in White House.
Oh,
how about that?
Cool.
Any tornado potential here? The very end for Kingfisher. Nope, it died. It was there, but then it died. And you know why? Because it's not oriented north and south. It's not quite. It's more parallel to the line. All right, guys. Thanks for watching. Appreciate you. As always, thanks for tuning in. You guys got to get to bed. It's midnight.
Yeah, it's late.
Yeah, you got 1,000 people on here. Bunch of night owls, man. That's for sure. All right. Well, God bless. Have a wonderful Tuesday, and we will be watching it close. So take care. Are you going to hit the gym tomorrow?
Oh, yeah.
Oh,
Of course.
yeah. Are you not storm chasing?
Um,
No, hitting the gym
We'll
and
see.
storm
Yeah,
chasing.
we'll
I
see.
like that. Are you going?
I don't know.
Stay tuned. We'll find out. Thanks for watching, guys.
Mystery.
Bye-bye.